We are now live, so let's get this started. So, start with the first preparation assignment. I'm sorry, let's start with the preparation assignment. So, Part 2, a study by the National Association of Realtors reported in 2004 that second home sales accounted for more than a third of residential real estate transactions. And the reported average age of a person buying a second home as an investment rental property was 47 years. The real estate agent wants to estimate the average age of those buying investment properties in his area. He randomly selects 15 of his clients who purchased an investment property and obtains the data shown. What are the requirements for creating a 95% confidence interval?
Okay, I already have the data inputted. So let me see, what it's asking. So, it's like a random sample and means normally distributed, right?
Yep, that's what I got too. You good with that one, Veronica?
I'm sorry, hold on. I'm having a little trouble opening that page. Give me a second.
Okay.
Sorry.
No worries.
I just got your text. Sorry, guys. I don't know why it's not opening. Just go ahead and continue. I'll catch up right now.
Okay. So, number 2, with the data above, create a 95% confidence interval to estimate the mean age of all clients in investment property. Input the numbers you computed in number 7 of part 1 into the confidence interval formula. Show your work below. The t-score for a 95% confidence interval, the t-distribution with 14 degrees of freedom is 2.1448. So, what I did was I took the sample mean, and it was 46.73, and I did minus 2.1448, multiplied that by 8.83 over square root of 15. Then I got 41.8. Is that what you got, Clayton?
Well, I just, so far, I've just used program, and I got 41.8 and 51.6.
Sweet.
I need to take a look at the equation again. Let's see.
Yeah, so what you do is, it's basically like...
yeah, mean subtracted from population mean, divided by, I guess, what's this again? Standard deviation?
Well, actually, it's not that. It's actually similar to the, I'm sorry, it's more similar to the one we did yesterday. I'm sorry, what was that one? Oh yeah, it's the, hang on.
Well, yeah, there's, where is it again? I get what you're saying. I mean, it's like the mean minus t multiplied by s divided by the square root of n.
Yeah. Bless you.
Is that right?
Yeah, that's right. So that's the one you use. And that's the
S
answer I
the
got.
square mean, or I mean, is S the standard deviation?
S is the standard deviation. It's the sample standard deviation. So
Mm-hmm.
the
Yeah.
sigma is the standard deviation for the population.
Yeah, I remember sigma at the very least.
Yeah. Yeah, so S is basically sigma except for the sample.
Mm-hmm.
Cool. Veronica, are you with us? Is she not there anymore?
I guess not.
Excuse me. No, let's just keep going.
Oh, so what would the S be? Would that be the 14 or would that be
It's
2.1448?
it's actually S would be 8.83. It's the standard deviation computed in number 7.
Oh, wait. Oh, okay, so it has it on there.
Yeah, S is gonna be your standard deviation.
Okay, so 1 is like getting up to that point, and then part 2 is like you already have the data, you're just using it from 7.
Yeah, exactly.
Ah, man.
Okay. Let's go to the next one then.
Hmm.
It says now create a 99% confidence interval to estimate the mean age of all the clients who built an investment property. Follow the same rounding rules as above. The score for a 99% confidence interval from the t distribution of 14 degrees of freedom is 2.9768. And basically I replaced, all I did was replace 2.1448 with 2.9768 in the last equation, and I got the correct answer, which is 39.9 and 53.5.
What now?
So we're on number 3.
Yeah, I know we're on number 3. I can understand what. Oh, hey, I get what you were saying with switching the numbers.
Yeah, exactly.
What did you say again with for that?
You see you replace 2.1448 with 2.9768, because that's the new degrees of freedom, whatever. Oh, I'm
Yeah.
sorry, it's the new confidence interval. No, the
Oh, okay.
the t-score, the t-score.
I see what you do.
Okay, then
let me-
that's all you replace.
Let me calculate that myself on my own without using the program, just to make sure I'm understanding it right.
Okay.
Let me see. Let me. And let's see. Okay, yeah, I'm calculating it right.
Okay, cool.
Yeah, I got like 39.9. And that's what I got on the program as well. Is Veronica still not here? Nope.
Let's just move on. We'll get her caught up. I want to get the fish. Sorry, hang on.
Oh, so 4 is all about doing it on the program while 2 and 3 is doing it by hand.
Oh. So number 1. So number 4.
Yeah,
Is doing
number
it by the
4
program?
is number 4 is basically figuring out the same thing, but you're using the program.
Oh, see, today was the first day that I used this SPSS thing, and I don't know. It didn't give any instructions. I thought maybe I was wrong. Maybe I couldn't find it, but it didn't give
Well, I
me,
used the Excel.
yeah, I didn't find any instructions for using Excel.
Huh?
But I couldn't find any instructions for using Excel. But did you just? Were there some instructions for using Excel?
Yeah, I mean over each SPSS file, or I mean not file, instruction.
Mhm.
There was the Excel instructions.
Oh,
I
I
mean,
bet you. I know what's wrong. I know what I did wrong.
yeah, in lesson 11, there, I mean, above the blue box that says
Aha.
SPSS instructions, it's Excel instructions, and there's a blue highlight at the top of it on the first Excel instructions box. And it's basically the same thing as the last thing we used, the quantitative, descriptive, or something like that. We just copy and paste the means and put them into the column, and then we can mess around with the confidence level, the null hypothesis, and also the type of test, as in greater, less than, not equal to.
Hmm. Yeah.
So basically, a lot of it, what we calculated with the null and the alternative hypothesis, that is calculated in there.
Hmm.
So I find that, I mean, pretty nice or pretty useful.
Cool. Let me see if I can um, figure out how to compute it. Hey, could you do me a favor? Could you read those numbers off to me? It'll be easier if you read them off to me. Those numbers from number 1.
Um,
I'm gonna type them into this.
okay, so 27,
Okay.
49, 56. Oh, you go that fast.
Sorry, hang on. Okay, 50. I'm on 55 now. So after that.
So it's 27, 49, 56, not 55.
What are you up to now, man?
Okay, I think you have a different. Hang on, I got it. Never mind.
Just make the window smaller and then like scoot it to the side so you can just type it into the box. That's what I did.
Hey guys.
Hey, Veronica.
There you go.
Sorry.
No worries. How you doing?
I think what happened is my internet isn't working well.
That's okay. We're just plugging along here.
We're on number 4.
Okay.
Kevin's trying to figure out how to use this program. Do you know how to use the program?
The Excel?
Mhm.
Yeah.
Oh, okay, good.
Okay, I see. All right, that makes sense. So I was overcomplicating it. Huh. So, huh. How do you change it to? You guys are on a different program. Huh. All right. Well, oh, dude. Whatever.
The quantitative interference resources, right?
Sorry, what was that?
The Excel spreadsheet that we're using is that quantitative interference procedures?
Yeah,
Okay.
I was not smart and I didn't realize that you could use Excel. So I'm using the SPSS at the school computer. That's why my camera's off, because it feels weird. Have a camera on in this public place. But you can still hear me, so it's all good. So basically, what you do for number 4 is I figured the answers out the old-fashioned way. I couldn't figure out how to do it in the computer, so.
You're kind of broken out. What?
Oh, it's okay. I wasn't saying anything important, so don't worry. So let's just go on to number 5.
Were you able to figure it out?
Yeah, I figured it out. No worries.
Okay.
How does the margin of error of the 95% confidence interval compare to the 99% confidence interval?
So, from the last lesson, what we learned is, excuse me, that as the percentage gets higher, that it increases. So 95%, or the margin of error for 95% is lower than 99%.
Sweet.
Wait, hold up. Okay, yeah. I think. I don't know. That's kind of what the answer says.
Yeah.
But,
No, it's true.
well, yeah, that's kind of. That's what I remember from this lesson, at least. Being a bit.
Yeah, well, if you compare, just compare the numbers of that, you can see that 99% confidence interval is a lot, or it's at least a little bit wider. The other one. Let's go on to number 6. Let's see, number 6 says, rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different from the national average of age 47. Use the 0.05 as your level of significance. Follow the following sequence of steps. Fill in your answers at each step. There are your work. So we got 6.
47.
That would be the null, and then the alternative would be not 47, right?
Huh? Oh, well, I'm putting in oh, hold up. My number A, state the null. Oh, okay, so, what is it? The null hypothesis equals 47, and then
The alternative is
does
not.
not equal to 47. But what equals it now? I think population mean does not equal to 47.
Yeah.
Yeah, exactly. The population mean is not equal to 47.
Okay.
Very good. Okay.
I was kind of like skipping ahead and putting data. Um, so let's see. Oh, compute the test statistic. First, compute it using the formula showing your work below. Then check this test statistic by inputting the data into the software.
So, what is the let's see. That's right. Okay.
So let's see. It's 46.73 minus 47. Wait, no, it's no, yeah, it's 46.73 minus 47 divided by 8.83 divided by the square root of 15. Let's see. 46.73 percent divided by okay, so I got negative 0.0118.
0.0118, or is it negative 0.118?
Yeah, I got that too. Negative 0.118.
Oh, really?
Oh.
Let me see.
Oh,
You're doing the right order.
I accidentally put 88.3 for the standard deviation. That's why. I don't know why. Oh, okay. Yeah, never mind. That's why, because it's one decimal place over.
Okay. So now we state the degrees of freedom, which would be 14, because the degrees of freedom, it's the sample size minus 1.
Oh, so did you guys hear me? Because that broke it, or I guess logged out for a sec.
No, I totally heard you, unless you said something. Oh, the last thing you said was that it was 8.83 instead of 88.3.
Yeah, I was asking for how we got the state degrees of freedom, but I mean, I just looked it up. I mean, n minus 1, so it's 14.
Yeah.
It's always like that, right?
Huh?
It's always that, the n minus 1?
Yeah.
Yeah, for the degree of freedom.
Okay, sketch the t distribution and shade the area which represents the p value. I'm not sure how to do that.
Okay, wait, I'm a little, here, okay, what do we do for D?
For D,
Yeah,
I don't know how to sketch the t distribution.
me
I'm
neither.
sure it says in the.
I mean, I have, well, yeah, I have the p-value for it, like using the information. Well, hold on. Okay, so maybe not. I mean, the p-value on the chart is, or the quantitative inference program, it's 0.9085. to where this is on the answer sheet 0.9077. So there must be something that's not input in there. Something's a little off on this. Oh, okay, maybe that's why. No, no, that's not it. Oh well. Maybe he did a typo or something.
Well, I don't know. But let's just move on from this one because I didn't really learn how to draw on these graphs like perfectly, you know. But I guess, well, you know what? If the t-score, I don't know. If the t-score is
Ooh, ooh,
certain thing, that's what.
okay, I messed something up. Crap. And it won't let me go back. Okay. This is getting a little ridiculous. Okay. I'm just gonna start a new chart. I don't know what I did. I screwed something up. And it won't even let me out of this program.
Well, one thing's for sure, guys. Your wonder. Hang on, I might.
What the heck?
It's weird. I don't know. See the sample size. Well, you know, the sample size is gonna be.
I don't know what to do.
What's wrong?
I don't know. I accidentally did the same thing I did before. So I have to force quit the program.
Okay. Well, what I was saying was, since the sample size is larger and the degrees of freedom is large-ish, I was just looking at the reading, and basically, it's gonna look like a normal bell-shaped curve.
Oh, that's what it's talking about. I thought it was whatever it has to do with the first part of the lesson.
Uh,
But I didn't look at the lesson.
yeah. So it's gonna have negative 0.118 and 0.118 on either side, and then the p-value is between that and the two ends. It's on the two ends.
Wait, how did you get all that?
I know that the graph is going to look like a bell-shaped curve because the
Yeah.
degrees of freedom is higher. If it's like around 15 or higher, it's going to look like a normal distribution, not like a bell-shaped curve. But if it's lower, it's like it looks lower than a curve. Like it looks it doesn't reach the same height as a curve would. But anyways, that doesn't matter. All that matters is you have negative 0.118 on one side, and then 0.118 on the other side, and 0 in the middle. And then you do a bell-shaped curve, and then you're going to have some room on either side of the two wings, and those are going to be the p-value. So you feed those in. Kind of, I don't know. I don't. Does that make sense?
cutting out. Do you guys hear me?
What's that?
I said let's move on because my chat thing. I think I'm cutting out.
Right. So E, use the software to compute the p-value.
So the answer key says it's 0.9077, but from what I got on the chart, it's like where is it again? 0.9085, and I don't know why.
Well, the
Well,
sorry. The crud, I can't think. If the answer key says it's 0.9077.
I mean, what'd you guys get using the program?
I'm missing something. I don't know. What's the level of you know how it says use 0.05 as your level of significance? Where do you put that on the chart?
I don't think you put that on the chart.
Yeah, you don't need to worry about that because you just need to get the p-value. And then once your p-value, if it's higher than the level of significance, then you fail to reject the null hypothesis. But if it's higher, lower, I'm sorry, lower than the level of significance, then you reject the null hypothesis. So I don't know how to get the I don't really know how to get the answer with the program. I'm not doing. I guess.
Well, either answer, since it's above 0.05, we fail to reject the null hypothesis for L.
Yeah.
Okay.
Mm.
Yeah, I don't know. I don't know what I'm doing wrong. It's not coming out. I got 0.5 as a p-value.
I don't know how to find the p-value. Yeah, maybe it says here. Does it say in the? Does it say in the? I don't know.
Well, did you guys want to try our luck at the quiz?
Yeah, that's. Oh,
Okay.
yes.
No, I like that. Okay. So I need to re-log in before I can start the quiz. Okay. I'm ready when you guys are.
All right, I'm ready.
So let's go ahead and start. So we have 13 questions this time. Well, total of 15. But, yeah, 13 questions. So
Why don't you lead us off?
in previous lessons, we have assumed that assumed the population standard deviation sigma was known. In this lesson, we are making a different assumption about sigma. What has changed? We assume that a sigma is unknown, I think.
Yeah. Yeah, I agree with that.
Okay. Number 4, the null hypothesis is the population mean equals 8, and the alternative hypothesis is population mean is greater than 8, and the population standard deviation sigma is not known. Becca collects a sample size n equals 9 and computes the mean equals 11 and the standard deviation equals 6. Use this for 4 and 5. Is sigma known? And I guess, yeah, no, it's not known.
Yeah, it's not.
Okay, and then what is the value of t? So 11 minus 8 divided by,
Hey, can you guys hold on? Can you hear me?
Yeah.
Hello?
Yeah, we can hear you. Can you hear us? Hello?
are you good? Is everybody there?
Yeah, I'm here.
Okay. So far for t, I think I got 1.5.
Let's see.
Hello?
1.5. Hello,
Yeah.
Veronica?
Can you guys hear me? Because you guys keep
Yeah, we
freezing
can
up
hear
on
you.
me.
We can hear you.
Okay.
Okay. That was me, Veronica. Okay, what's the sample size? And so,
I'm sorry, hold on. Can you guys, do you mind holding? I'm trying to open it and it's not, like, I don't
I'm
know why
trying.
this is freezing on me today.
Oh, you still haven't opened the quiz?
No, I haven't been able to. It doesn't let me.
Ah. Okay. Yeah, we'll wait.
I'm sorry.
No worries.
I'm thinking maybe I'm just gonna do it on my iPad because it's not, for some reason, it's not opening. Oh wait, okay, I think I got it. Okay, so I just, the only one I didn't get was number 3.
Huh?
Number 3. I mean number, yeah.
Number 3.
Uh-huh.
That was that sigma is not known.
Okay. Okay, so we're on 5, right?
Yeah.
Okay.
Hang on a second. Let me pull something. Okay. All right, I'm ready.
How'd you get 0 for number 5? I did hear
Oh,
that.
we didn't get 0.
0.
I mean, not 0, 0.5.
We got
I got
1.5.
1.5. Did you hear me?
We got
Yeah.
1.5.
0, 1.5?
No, just
I got
1.5.
1.5. Is that what you got, Kevin?
Yeah, I did get that.
Okay.
The formula is at the bottom of lesson 11.
Yeah, I just, I think what's got me confused is, what's the, oh,
Yes?
never mind, never mind. I was looking at the wrong thing. I got it. I didn't realize the 11.
Alrighty, so use the following values. We're on number 6 now. So use the following values which were pulled from the data file body temp. Copy and paste them into the software you decide to use, Excel or the SPSS, using the null hypothesis of 98.6 and alternative hypothesis of the mean is less than 98.6. The level significance alpha equals 0.05. What is x? Round to 3 decimal places. Let's see. It would be
So
98.234.
Just give me a sec. Oh, okay. Whoops. Okay, just this data. I actually pulled up the actual file. And that's less results.
okay, so
Give me a sec to re-pull up the program.
okay, so not here is x 05.
I think that works. Hold up. Okay, there. Oop.
Where does
Okay.
that? Do you put no significance anywhere?
9.6. Oh no, wait. Oops. 98.6. And okay, less than. Okay, so let's see. So it's asking what is the mean, and from the data I got from the data I have, I got 98.22.
I do too. That's not what it's asking for not for the mean, right?
The number 6 is asking for me.
Huh?
Number 6 is they're asking for the mean. The X with the line over it, that's the mean.
That's right.
Okay. Kevin, are you still there?
I just got back, I think.
Okay.
Couldn't hear you
So
So the mean is 98.22?
98.22.
Oh, I got 98.23, but let's see. Oh, 3.
What'd you say? You cut out.
I got 98.234. It says it's around 3 decimal places. Are we talking about
We're talking about the mean.
6?
Number 6, yes.
Yeah. Yeah, it's on my program. A different one. So I got 98.234.
So on mine, I mean, in the box it says 98.220.
Oh, really?
Mine too.
You guys are using Excel though?
Yeah.
I'm using SPSS, so maybe it'll. I think it'll.
Did you make sure you hided all the data in like the actual quiz and not in the separate file?
I'm pretty sure it works a little differently in SPSS because it's all one file. It's not just differently.
Okay.
Anyways, I bet you that since people use both, I bet you're going to be right either way. So I think I'm just going to put that in there. You guys,
Okay.
so no worries. So what is what is S? So mine is showing 0.7376.
Mm,
Are you guys there?
yeah. What is that's the standard deviation, right?
Yeah. It's the,
On mine it's showing 0.922.
oh my gosh, I must have, something's
That's what mine is showing.
Yes. I don't know how to change it. Oh, maybe I'm looking at the wrong one. No. Huh, that's weird. So you got, what'd you get for the standard deviation again?
0.922.
Who's putting that in? And
For the T-score, did you get minus 1.843?
this is for the body temp one, right?
Yeah. We're not using the file, we're using the data that's within the within question 6.
Oh, that's
I
why.
asked you that before if you were using the data in the file or the data in the quiz.
Yeah, I misunderstood your question. So now I understand.
So open up a new file or click undo and then input the data from question 6 because that's only like about 20 different answers. Or, I mean 24 or yeah, no, about 20 where the file is like 150 or something like that.
Yeah, that makes a lot of sense now. Okay, cool. Sorry about that. That's right. Hang on, let me make sure I got the right one. Okay, I think I got them all right. Okay, sweet. So now we do this and this.
Oh man, I forgot to do last week's collaboration.
Oh, me too.
Okay. All right, now I'm in the right place. So what did you guys get for the T-score? About 476.407.
What did you say?
Or what did you get for the T-score?
Negative 1.843.
What did you get for the?
The p-value is 0.040.
I think I'm still getting something wrong. Hang on. Hang on a second. Let me do this right. Okay, hang on. Sorry, guys.
I don't get this.
Okay. Should be all right. Now analyze.
Is he still there?
Yeah, I'm still here. I'm just getting totally different answers still from you guys, even though I had the right data in there. So I have the mean is 98.220. I think that's right, right? That's correct.
Yeah.
And then I have the standard deviation as 0.9220.
I can't hear you.
I have the standard deviation as 0.9220.
Yeah.
That's right?
Yeah. Don't
Oh.
put the 0 though. And we're doing it 3 decimal places.
Oh, okay, I got it. So, and then for the t-score, though, I got something completely different, I think.
What'd you get?
I
Did
got
you change the less than?
change the lesson.
Type of test?
Sorry?
I couldn't hear you. What?
No,
For the
I'm just asking him if he changed, because you know how you do the, hold on. I have to see what I had it. You know how you put in the values and then you put in the null hypothesis and then the type of test, did you put less than?
Oh, that might be it.
Yeah. Because that changes it, like, big time.
Yeah. Aha, okay. Oh my gosh, I'm having so many struggles. Okay. Yes, 98.6.
So your t-score should be minus 2843.
Oh, gosh. Okay, now. Okay. 98.6.
What?
Okay, negative 1.843.
Yes.
Okay, finally.
Hey, I have a question. When you know how like on number 6 it tells you 98.22? Were we supposed to put the 0 or not since it's 3 decimal places?
I don't think so.
It's just 0.922.
Okay. Just want to
Alright,
make
so-
sure you bother putting the 0.
Yeah. So what is the p-value?
0.04?
Sure. Where does it say that? How did you figure that out?
Huh?
How did you figure the p-value out?
It tells you, doesn't it? Or did I do that wrong?
I don't know. Oh, wait. I think I have 0.081 as the p-value. Oh, wait. I don't know.
No, it should be 0.040481822. What did you get, Kevin? No, wait. I mean, Clayton, sorry.
4?
Huh?
What did you get for the p-value?
9?
Yeah.
For number 9.
0.04?
Yeah.
I'll just go with that. I can't find it on mine, so.
You guys ready for 10?
And then number 10, I think it's reject the null hypothesis.
Yes.
Yes. Okay. I already started on the next one.
Yeah, I'm up to 14.
I'm glad you guys are doing that because
So,
otherwise it'd be forever.
so for 11, I got 0.995.
I did too.
For 12, I failed to reject the null hypothesis.
Yes.
13, I put decrease.
It what?
For 13, I put decrease.
Yes.
For 14, I decided to fail to reject the null hypothesis.
Wait, why?
Well, let's see. I mean, the p-value for that was 0.995, right?
Yeah.
Oh, wait, hold up. I'm talking about 14. So basically for 14, all I really did, or let's see, for 13 and 14, all I really did was change it to less than, and the p-value is 0.502 for that. So, I mean, that's still above 0.05. So I failed to reject the null hypothesis.
Sounds good.
So I'm on number 15 right now.
Okay.
Compare the width of the confidence interval for question 11 to the confidence interval for question 13. Which one is wider?
It says there, I mean, from going back and forth from equal to less than, the confidence level is the same. The p-values still change, but the confidence interval does not.
Oh yeah.
So
they're
should
the
we
same.
submit it?
Right?
Sorry, what'd you say?
They're the same?
Yeah.
So, should we submit it?
Yeah.
Yep.
100%. Cool.
I got 100.
Awesome.
Me too.
Woot. Alright, guys. My computer's about to die, so I will push stop broadcast.